Hello students, so let's start with unit 4. So this is the second part of unit 4. So here in this part we'll be discussing about cloud database, cloud computing, fog or edge computing. So first we'll see what is meant by cloud database. Basically if you consider database, it is a database that is deployed and delivered and it can be accessed in the cloud. So you would have used so many types of cloud databases. So these cloud databases organize and store structured, unstructured and semi-structured data just like traditional on-premises databases. So, however, if you consider the other things, considering speed, scalability, agility, and reduced cost, the benefits are really very high comparatively with the normal databases. So, a cloud database is a database which is run in a public or hybrid cloud environment to help organize, store, and manage data within an organization. So, whenever you consider a cloud database, it is managed by a database as a service. So, it is often described as DBAAS, and it is deployed on a cloud based virtual machine and self managed in an in house IT team. So, moving on to the types of cloud databases, we have two different types. One is relational cloud database, and the second type we call it as non relational cloud databases. So, why do we use cloud database? So, that's the main question here. So, the reason of using the cloud database is the amount of data generated and cloud and collected today is growing exponentially nowadays. So we are using varied varieties of data, and data can reside across on-premises databases and distributed cloud applications and services. So we have different types of data which is difficult to integrate using traditional approaches. So along with that, we are using real-time data processing. So it becomes an essential part to business, and there are so many delays and lags in data delivery to mission critical applications that would help in catastrophic consequences. In addition to that, we have cloud adoption, which signifies the data continues to evolve. So we have legacy databases where we have significant challenges. So cloud databases provide flexibility, reliability, security, and affordability, and more. So it provides a solid foundation for building modern business applications. So when you consider relational cloud databases, it consists of one or more tables of columns and rows, which will allow you to organize in a predefined relationships. So this helps you to understand how the data is logically related. So these databases typically use fixed data scheme, and it can use structured query languages to query, and it can and we can use that to manipulate the data. So they are really very highly consistent, reliable, and it is best suited to deal with large amounts of structured data. So moving on to some examples of relational cloud database, we have SQL Server, Oracle, MySQL, Spanner, Cloud SQL, and so on. And we have some non-relational cloud database which consist of MongoDB, Redis, Cassandra, HBase, and Bigtable. So when you consider non-relational cloud databases, it can store and manage unstructured data. For examples like email, mobile message, text, documents, surveys, and other information from the sensors and so on. So they don't follow a clear defined schema like relational database, and it will allow you to save and organize information regardless of its format. So it is mainly used to manage unstructured data. So in particular, they can rapidly adapt to changing workloads and demands without increasing the workload of already overburdened teams. So moving on to the next part, we have cloud database management. So here we can consider cloud database which follow two deployment models. So first we'll go on to traditional self-based cloud databases. So here the cloud database is installed and it is hosted on a virtual machine. So this traditional self-managed cloud database is considered to be a traditional deployment model. So with this model, you can maintain control over your database, and you can handle different IT teams, and it is still responsible for database management and maintenance. So next, moving on to the next part, managed database service. The cloud database is accessed as a service, so it runs on the cloud service provider infrastructure. So this provider is responsible for most of the operational, maintenance, and administrative database management tasks. So this typically involves automated provisioning, scaling, security, and it also helps in health monitoring using these types of database services. So moving on to the next part, we have some examples for cloud database. We have cloud, Google Cloud Platform, Microsoft Azure, Amazon DynamoDB, OpenStack, IBM DB2, Snowflake, and then we have Google BigQuery. So these are some examples for cloud database. When you consider the conclusion of these cloud database, it is the major important things in businesses, and it is used to choose a cloud database that it is perfectly fit for the business type based on its features. So hence, if you have a database, you should make sure whether it consists of an online or an independent scalability to ensure the company's needs and other workloads. Therefore, we have some cloud databases which can which can have a detailed knowledge about the cloud databases, and we have some examples which are listed in the uh, slide. So next we'll move on to cloud computing. So before moving into cloud computing, you have learned about cloud database, and we'll see some introduction part of cloud computing now. So cloud computing is a technology that allows you to store and access data and applications over the internet. So instead of using your computer's hard drive or a local server, you can use it via cloud. So in cloud computings, you can store different types of data such as files, images, videos, and documents on remote servers and access them anytime from any device connected to the internet. So moving on to the infrastructure, cloud computing depends on remote network servers hosted on the internet to store, manage, and process data. So considering the on-demand access, users can access cloud services and resources on demand, scaling up and down without having to invest in physical hardware. So there are so many types of services which is provided by the cloud computing. So cloud computing offers benefits like cost saving. So it helps you in scalability, reliability, and accessibility. So it reduces capital expenditures and it improves the efficiency. So moving on to the architecture of cloud computing, it refers to some components and subcomponents for cloud computing. So basically we have three types of components here. So first we have front-end component, so that we call it as fat client and thin client. And next we have backend platforms, we call it as servers or storage. And next we have cloud-based delivery and a network where we have the internet, intranet, and intercloud. So when you consider the cloud computing architecture encompasses the essential components that enables cloud-based services and infrastructures. So when you consider front-end interface, we have fat clients and thin clients. So we'll see what are they, what are the types of devices. So fat clients are devices with substantial local processing power, and thin clients are nothing but it is a lightweight interfaces relying heavily on cloud resources. Moving on to backend platforms, you can have servers and storage. So servers handle computation, application logic, and data processing, whereas storage systems can manage and retain data securely and efficiently. So moving on to the cloud-based delivery and network. So we have intranet, internet, and intercloud. So internet is nothing but public access to cloud services can be provided. So moving on to intranet, we have private cloud access within an organization. And next we have intercloud, so that is interconnected cloud environments for broader scalability and redundancy. So these are the architecture of cloud computing, and these are the main components of cloud computing. So moving on to the cloud computing architecture. So this is the diagram we have. So we have three components mainly. So one is backend, the second is front end. So connecting all the front end and the back end, we have internet. So this diagram represents the cloud computing architecture, where it is divided into front end, back end components, which is connected via the internet. Okay, so first we'll see what is front end and client infrastructure. So it refers to the user side hardware and software. For examples like user side hardware and software, we can consider computers, mobile devices, browsers, or applications that will interact with the cloud. So moving on to the back end, we'll have some applications like applications. We have service, runtime cloud, storage, infrastructure, etc. So the actual cloud applications accessed by the clients. So when you consider the services, we have cloud services. We call it as SaaS, PaaS, IaaS, that provide resources and functionalities to the client. So moving on to the runtime cloud, so the execution environment where the applications run. So it also provides the runtime services and and it manages the resources. So we also have storage. So storage is nothing but it handles cloud's data storage system, which can store and manage user data. So moving on to the infrastructure, it considers the physical resources like servers, network, hardware, virtualization, which is mainly used for powering cloud services. And next, moving on to the management part in the backend, it manages the resources, applications, servers, services, and it ensures system coordination. So management is mainly used for system coordination, and it performs activities like resource allocation, monitoring, scaling, and etc. So moving on to the security, which is present in the backend services, it provides protection, authorization, authentication, and data privacy in the cloud. So connecting element, we call that as internet. So it's nothing but the communication medium that connects the front end clients with the back end cloud services. So front end, we can call that as client infrastructure. So back end, we can consider application services, runtime, cloud, storage, infrastructure management, security, and so on. And connecting both front end and back end, we can use internet. So this is all about the cloud computing architecture. So moving on to the next part, we are going to see the types of cloud computing services. So here you will be learning about four types of services. First, we call it as infrastructure as a service, that is represented as IaaS. And next, we have platform as a service, we call it as PaaS. And next, we have software as a service, SaaS. And next, function as a service, that is represented as FaaS. So next, considering the infrastructure as a service, we'll see what is meant by IaaS. Okay, so it's a type of cloud computing that gives people access to IoT tools like virtual computers, storage, and networks through the internet. Okay, so first we can consider the flexibility and control of IaaS delivers, which can be used in virtualized computing resources such as virtual machines, storage, and networking. So it can give users full control over the operating systems, middleware, and the applications. So considering the cost efficiency of hardware, it can eliminate the need of physical infrastructures. So IaaS reduces the capital expenditure and it lowers the maintenance cost, making it as making it as a financially attractive option for business. So moving on to the scalability of resources, we have scalable resource management, cloud-based infrastructure as a service management, which allows dynamic scaling of hardware. So these hardware resources is based on the real-time demand, ensuring optical performances while maintaining cost effectiveness. So this is all about infrastructure as a service. And next, moving on to platform as a service. So we'll have a brief introduction about platform as a service. So it is a cloud computing model where a third-party provider offers the software and hardware tools which is used to develop, test, and run applications. So we have some simplified development PAS system. So this simplifying the development can be considered for service which offers application development by keeping the underlying infrastructure as an abstraction. So moving on to enhancing the efficiency and productivity, we have it can considerably reduce infrastructure overhead, and it gives a proper development cycles. It can shortens time to market, and it supports rapid iteration and development. So when you consider simplified development PAS system, it manages infrastructure management, and it enables developers to concentrate on the application logic. While performing these activity, the platform handles the servers, networking, and the runtime environments. So moving on to the enhanced efficiency and productivity of cloud computing, by reducing the overall infrastructure overhead, we can access all the information, and it supports rapid iteration and deployment. Moving on to the automation of scaling, we have PAS platforms which can dynamically manage resources allocation. So it ensures optimal performance and workload efficiency as application demand fluctuates. So moving on to the next part, we have software as a service. So that is represented as SaaS. So a common example we can say it as Google. When you use Google Docs, this can be considered as a software as a service. So when you use Google Docs, you can write and share documents online without downloading any software. So the software is hosted by a company, and you can use it by logging in through a web browser. So moving on to the collaboration and accessibility of SaaS system, it enables seamless access to applications from any device with internet connectivity, and it also promotes effortless collaboration without the need for local installations. And next, we consider automated updates where we can provide providers handle software maintenance, and it can deliver automatic updates, ensuring users always benefit from the latest features, performance improvements, and security patches. Next, considering the cost efficiency, uh, this particular SAS reduces IT overhead by eliminating the need for individual software licenses and infrastructure support. So it makes it a budget-friendly solution for organizations of all sizes. So this is all about software as a service. And next we have function as a service. So here we can consider what we can see what is meant by function as a service. So it is a cloud computing service that allows customers to run code in response to events without managing the complex infrastructure. So when you consider an example here, you can consider AWS Lambda. So you can write a function that resizes images whenever someone uploads a photo to a website. So it is not necessary to keep a server running all the time. So AWS runs your function only when a photo is uploaded. So considering the benefits, we have event driven execution. So yeah, here you will be having some maintenance of servers and infrastructures, and we can facilitate the developers to run code as a response to events. So when you consider FAA system, it is a cloud computing model that enables developers to execute code in response to specific events. So without the need to manage servers or infrastructure, you can simply write the function, you can upload it, and the cloud providers runs it only when it is triggered. So for example, billing is based solely on execution time, so making it is highly cost effective. So when you consider the advantages, we have event-driven execution, cost efficiency, and scalability and agility. So here we can consider. So when you consider event-driven execution, this particular part helps the infrastructure, which is concerned about allowing developers to focus on writing event-triggered functions like the platform handles, provisioning, and execution. So moving on to the cost efficiency, it operates on a pay-as-you-run model. So it ensures the users are charged only for the actual compute time which can be used. So eliminating the idle resource cost. Considering the scalability and agility, so it is considered to be serverless architecture, so which automatically scales with the demand. So it also enables rapid development. The deployment is very easy, and the responsiveness to the fluctuating workloads is also managed properly. So this is about the function as a service. And next, moving on to the next part, we'll have deployment models. So here you will be learning about the deployment models. So we have three types. One is private cloud, public cloud, and hybrid cloud. So, when you consider private cloud, it offers enhanced security and control. So, considering the optimization, it is very specific to organizational needs. So, it is ideal for enterprises with strict compliance requirements, and it is sensitive to data handling. So that is all about the private cloud. And next, moving on to public cloud, it operates on a pay-as-you-go model. So it provides scalable and accessible resources to multiple users, and it delivers cost-effective solutions for general-purpose enterprise workloads and services. And next, moving on to hybrid cloud, it integrates both private and public cloud environments for seamless data and application. So this is very important where we can consider both private and public clouds. So this private cloud enables strategic resource optimization. So it also considers sensitive data which can reside in the private cloud while scalable workloads run in the public cloud. So these are the cloud deployment models where you have learned about the private cloud, public cloud, and hybrid cloud. So next, moving on to this slide, we are going to see what is meant by cloud security. So to recommend all these practices, it is needed to protect data applications and infrastructures in cloud computing environments. So we'll be using all these types of assets to safeguard data, application, and infrastructure in cloud environments, and it can also be adopted in the organizations. So first we'll see about the data encryption. So you all know what is meant by data encryption. So encrypting the data both at rest and in transit can be considered here. So the data encryption ensures that even if it is intercepted, the information remains unreadable to unauthorized parties. And moving on to access control, so it enforces strict access policies, and it provides authentication protocols which helps restrict cloud resources, access to verified users, and thus minimizing the risk of data breaches. And moving on to multi-factor authentication, we call it as MFA. So this MFA strengthens the login security by requiring multiple forms of identity verification such as password, biometrics, or security tokens before granting access. So this is all about cloud securities. We have learned data encryption, access control, and so on. And moving on to some use cases of cloud computing, we can have some description about the data storage and backup, big data analytics, application development and testing, remote collaboration and productivity, content delivery, and streaming. So when you consider data storage and backup, so it stores vast amount of structured and unstructured data. So it enables automated backups, and it can be used in disaster recovery with minimal infrastructure. So when you consider big data analytics, it processes and analyzes data, large data sets using a scalable cloud resources, and it supports real-time insights. It also supports predictive modeling and business intelligence. And next we have application development and training, where we can rapidly build, test, and deploy applications using cloud platforms, where we can consider examples like PaaS systems. So, application development and testing also enables continuous integration and delivery pipelines. We have remote collaboration and productivity. So it uses SaaS tools like Microsoft 365 or Google Workspace for seamless teamwork. So here we can share documents, manage projects, and communicate in real time. And moving on to the content delivery and streaming, we can distribute via medias like videos, games, software via its servers for low latency access. So it also supports global audiences with scalable bandwidth. And next we have machine learning and AI. It can train and deploy models using cloud-based GPUs and TPUs. So it can integrate intelligent features into apps without local compute constraints. And next we have enterprise resource planning. So next we have enterprise resource planning. We call it as ERP. So it manages business functions like finance, HR, and it can provide supply chain via cloud-hosted ERP systems. So it can improve scalability and it can reduce IT overhead. So considering the security and compliance, it can implement cloud native resource security tools for threat detection, identity management, and compliance monitoring. So some use cases can also be used in healthcare and telemedicine. So it can store and analyze patient data securely, and it can enable remote consultations and diagnostics using cloud-hosted platforms. And next we have IoT and edge integration, where we can connect and manage IoT devices with cloud backends. We can process the data at the edge while syncing with centralized cloud systems. So moving on to some characteristics of cloud computing. So we have on-demand self-services, broad network access, rapid elasticity, resource pooling, etc. So when you consider resource pooling, we have network servers, storage applications and services, which can be shared across multiple platforms, and multiple clients are provided service from a same physical resource. And on-demand self services can be used along the services which does not require any human administrators. So users themselves are able to provision, monitor, and manage computing resources as needed. So broad network access, the computing services are generally provided over the standard networks and heterogeneous devices. And we have some advantages of using all these requirement, which gets over when IT resources that are able to scale out and quickly is based on the daily available basis. And we have some more things which can be used here in cloud computing. So here we have measured service, multi-tenancy, virtualization, resilient computing, and so on. So next we have flexible pricing models. We have security, automation, sustainability. So considering the flexible pricing models, we can use it as pay pay per use, or we can use based on subscription, or we can use based on some other pay as you go method, and so on. So based on the security, so cloud providers invest heavily in security measures to protect their users' data, and it can ensure the privacy of sensitive information. Considering the automation, cloud computing services are often highly automated, allowing users to deploy and manage resources with minimal manual intervention. So next we have edge computing. So we'll see what is meant by edge computing. So computation takes place at the edge of a device network. So already you know what is meant by a edge device. So that process we call it as edge computing. So it means a computer is connected with the network of the device, which process the data and sends the data to the cloud in real time. So it is known as edge computer or edge node. So with this technology, data is processed and transmitted to the devices instantly. So for example of edge computing, we can say autonomous vehicle edge computing devices, where we can use it in self-parking cars and so on. So these computing devices collect data from cameras and sensors on the vehicle, process it and make decisions in milliseconds such as self-parking cars. So in order to accurately access a patient's condition and foresee treatments, data is processed with a variety of edge devices connected to sensors and monitors. So with this technology, data is processed and transmitted to the devices instantly. So edge nodes transmit all the data captured or generated by the device regardless of the importance of the data. So next moving on to the fog computing. So fog computing is an extension of cloud computing. So it is a layer in between the edge and the cloud. So when edge computer sends a huge amount of data to the cloud, fog node receives the data and analyzes what is important. So then the fog node transfer the important data to the cloud to be stored, and it deletes the unwanted, unimportant data or keep them with themselves for further analysis. So by this way, we can use fog computing, which saves a lot of space in the cloud and transfers important data quickly. So finally, we will see what are the differences between edge and fog computing. So when you consider edge computing, it is less scalable than fog computing. Fog computing is highly scalable when compared to edge computing. So here in edge computing, we have millions of nodes, and considering the fog computing, there we have billions of nodes are present. So in edge computing, nodes are installed far away from the cloud. And when you consider fog computing, nodes in this computing are installed closer to the cloud. So remote database where data is stored can be used. So in edge computing is a subdivision of fog computing, and fog computing is a subdivision of cloud computing. So when you consider based on bandwidth, the bandwidth requirement is very low. So the data comes from edge nodes themselves. So that happens in edge computing. And when you move on to fog computing, the data requirement is the bandwidth requirement is very high. So data originates from edge nodes, and it is transferred to the cloud. So, considering the edge computing, operational cost is higher. So, here the operational cost is comparatively low. So, in edge computing, we have high privacy. So, attacks on data is very low. And in fog computing, the probability of data attacks is very higher. And in edge computing, edge devices are the inclusion of IoT devices or clients network. And fog is an extended layer of cloud. So moving on to the power consumption in edge computing, the power consumption is low, and in fog computing, the power consumption of nodes filter important information from the massive amount of data collected from the device, and it saves it in the filter high. So that type of activity is done in fog computing. And in edge computing helps devices to get faster results by processing the data, and in fog computing, it helps in filtering important information from the massive amount of data collected from the device. So, as I told you, there are so many millions of data, so the important data can be handled by cloud environment. So this is all about Unit 4, the second part. So we'll continue with the third part with the Raspberry Pi and Arduino. So we'll see what are the pins available in all those Raspberry Pi and Arduino board. So we'll discuss on the next part, yeah, that is part 3 in Unit 4. So I'll post that video also. Thank you all. Thank you, students.